Good morning. Thank you all for joining us. I'm Travis Cowan, Senior Sales Engineer at Long Building Technologies. Today, for our last installment of our coffee break for 2021, we are going to be talking about VFDs and smoke control ventilation in buildings. With us today to discuss the topic is Jim Wilson, who's our Regional Drive Specialist for YASKAWA, who has a lot of experience in this atmosphere, and we're glad to have you. Thank you, Jim. Take it away, sir.
All right, thanks for having me, Travis. Long's been a great business partner for 18 years now. It's really a pleasure working with you.
Thank you, sir.
You know, the thing about when there's a fire event in a commercial building, we really need to do two things. We need good air to breathe, and we need a safe way to get out of that building. And fire creates its own pressure, and then when we try to put it out with water, that creates steam, which creates even more pressure. And where's the smoke go? Well, it's going to seek an area of lower pressure. So here's a look at a typical installation. You can see the stairwell. In this case, the fan is at the bottom of the stairwell. And we can do two things here. We can create a positive pressure to keep smoke from entering that stairwell, or we can create a negative pressure if we're actually removing smoke from that stairwell. I mean, typically exit doors open into the stairwell. I'm sure that's not universal, but it seems to be that way. And so when you put a positive pressure, that makes it very difficult to open that exit door. And if we're exhausting it, well, it wants those doors open really easy. And anyone who's ever tried to open an access door in an air handler while it's running will understand what I'm talking about. So Denver Fire requires that under any condition during an emergency event, that those exit doors must require 30 pounds of force or less to get those doors open.
And that's every door in the stairwell, not just the one at the bottom.
That's everywhere you see a blue arrow up here, Travis, every one of those doors have to be accessible. The way we do this with the VFD is we have a transducer in the stairwell space that tells the drive, the VFD, what the reality is, what that pressure is. And we use a set point. We give the drive a set point that comes from the fireman's override panel that tells the drive what pressure to maintain. So as doors open and close, the fan speeds up and slows down to maintain the proper pressure in that space. So the first time I ever heard the term dynamic stairwell pressurization, I was told a story about the 9/11 attacks and the loss of life in the World Trade Center, and that a good percentage of that loss of life was due to the fact that the occupants could not get the stairwell emergency exit doors open. And as you might imagine, this is not a real easy task to perform, because we have no clue as to what doors are open, what are closed, what dampers are open or closed. And then there's the firefighters who prop doors open, to get access for their equipment. And again, Denver code, fire code requires that under any condition, there can never be more than 30 pounds of force to open these doors. When we go into the emergency override condition, all of the normal controls of the VFDs are disabled. You can't do anything with the keypad. It's all the building automation system controls are ignored, and the complete control of the VFD comes from the fire alarm control panel, and the drive also offers information back to that control panel. What the firemen want to know is, they want to know if that fan is turning. In an under torque condition. Maybe it's a belt drive. If the belts due to the fire condition melt off or somehow fail, and the drive's not producing any torque to the motor, well, we have an indication back to the fire control panel that gives them under torque detection. The drive's keypad actually says under torque detection. By the same token, if that fan is locked up for some reason, mechanically locked, well, we'll go to high current, we'll detect the over torque, and we'll also give that signal back to the control panel. And then there's also inputs such as proof that the drive is actually running. So in VFD life safety requirements, what we want to do is we want to allow the motor and drive to run to destruction. So the normal faults that we use to protect the motor and the drive, those are ignored. So no matter what condition we experience, that drive and motor are going to run till they physically cannot run. So we produce, this is for the Z1000 drive, and we have an emergency override application note. And you can see on the left-hand side of the panel, this is just a generic application. So you can see the red device over there when there's a switch turned at the emergency override panel. This tells the drive to go in emergency override. Then we've got a forward run contact to close. And keep in mind, this is just for forward run. We can make this reverse run as well, because you remember we talked about either positive or negative pressure. And then we've got the analog feedback coming back from the transducer so that the drive can try to maintain set point. On the right side of the screen, those top contacts, the fault relay output, those are disabled because remember, we're in emergency override. We're ignoring all of those faults. But the three contacts below, we have one set of contacts that tells the fire control panel we're in an under torque condition, another for an over torque condition, and then the last one running. Well, that can be running. It can tell the panel that we've met the set point requirements. So those are all programmable. Actually, all of those terminals, the S1 through S7 on the left, and those output terminals, those are all programmable. The inputs, there's probably 3.5 pages in the manual of possibilities for those inputs. And on the right side, there's a great deal of choices when it comes to what event we want to trigger those contacts. Now, this is an interesting real application that just came up not too long ago. And the thing about these Denver and the way that they do these buildings, we don't seem to see the same functionality spec from building to building. I don't know if it's a function of the fire inspectors or how they determine they want these to run. But in this case, you can see on the right side, we've got 3 zones. In each of those zones, they wanted a separate set point for each zone with a hysteresis of about 10 hertz. As an example, that zone 2, let's say that set point is 30 hertz. Well, with a 10 hertz hysteresis, that means that anytime that it's operating between, say, 25 and 35 hertz, it's going to close that run status contact over on the drive, the M5, M6 contact, so that the fire control panel knows that pressure requirement is being met. And then you also see on the very far left-hand side, in this case, we eliminated the enable switch to actually switch it to fireman's control panel because this is a dedicated drive. And so we're able to enable emergency override and give it a forward command with one contact closure. So let's assume that's set point 1. And then you drop down to S5 when that switch closes and S1 opens, then we go to the zone 2 set point, which is determined during startup. I'm assuming during the fan balancing portion of startup. And then the same is true for zone 3 with terminal S6. And you can see the table just to the right between the building and the drive. Yeah, right there. Those are the actual program parameters. In this case, we got the controls contractor, the mechanical contractor, the fire control panel contractor, my senior applications group, and myself on a Zoom meeting to work out the controls so that we could understand what the requirements of the building were. And then we sent, even in this COVID condition, when our testing labs are closed, we sent that senior applications engineer into the factory to the lab where he set up this series of programs and then tested it in a load and unload condition in the lab. And then we were able to tell the contractor, look, this is how this drive needs to be set up to achieve these results.
Yep. And Jim, in our experiences, I know you and I, Denver fire inspectors are, they all say some different things from time to time. I know we just ran into a job where they wanted 5 set points on a building, and we're able to do that, right? I mean, it's a case-by-case basis, but I guess what I'm driving towards is YASKAWA. We have plenty of inputs here on the side, and we have other ways to get more inputs if needed. So we can customize some of these inputs for a job-to-job basis is what I'm getting at.
So, Travis, I think you can do that, but I'm not going to say yes until we have this meeting, this functional meeting. And you can, just to your point, S2, S3, S4, and S7 are unused. So the possibility exists that we can add set points, but until we discuss this application, get senior applications group involved, my answer is probably. How's that?
Yeah, no, that's fair.
So the other design considerations on this type of system, I can't stress enough that the proper VFD sizing is very important. And it's important to note that VFDs are not sized in horsepower. I know it has horsepower on the nameplate, but these are power handling devices. These are rated in voltage and current. So we want to make sure we've got the VFDs sized properly. I'm not a mechanical engineer, so it's up to you guys to get the right fan curve. But I want to point out this UL 864 UUKL. This is a special UL standard for live fire safety systems. These are not this standard. If someone tells you this is required of the VFD, it is not. I've actually read the standard, and UUKL views VFDs along with motor starters or even soft starts as endpoint use devices. So the real brains are back in the fire control panel, so to speak, and the VFD does not have to meet that requirement. It's just a device doing what the control panel tells it to do. But the main thing, if you take nothing else away from this page, pay attention to the authority having jurisdiction. That fire control inspector, he has complete control of whether this thing is green tagged or red tagged. So we need to make the system work the way he wants it to, he or she makes it, wants it to work. So that's what we do at YASKAWA. We take what seem to be difficult situations and we try to make the complicated simple.
Jim, thank you very much. It's a pleasure to have you. Next week, or not next week, this is the last for the year. The next presentation, I apologize, is going to be January 7th, and that will be Mr. John Stumpf from Long. He is going to be talking about Carson Solutions and displacement ventilation in K through 12 applications. Again, that's January 7th. We hope to see you all there. So thank you all for joining us. I hope you have a great day. If you have any questions, feel free to reach out to your Long Building Technologies sales engineer, and we'll be happy to help you. Thank you all.
All right, thanks. Thanks for having me.
Thanks, Jimmy.